Hello and welcome to our SOL review of A.08 direct and inverse variation. Now what we're going to do is just kind of split it up into two camps, and we're going to talk about direct variation first. So if you look, the direct variation formula, y equals kx, it's actually very similar in a lot of ways to y equals mx plus b. And that's because they're actually pretty much the same thing. K is known as the constant of variation, what we keep multiplying the x value by. And it's very similar to slope. It acts the same way, in fact. There's two rules that are kind of followed with direct variation in terms of the graph. So it's a straight line, and it has to go through the origin, or 0, 0. So something like that. That would be considered direct variation, or like this, or even like a slow gaining one. Some real life examples could be like hourly wage, how much you're paid per hour, or you can even think of a direct variation kind of like an assembly line. Every hour will put together 5,000 boxes. Well, like 2 hours it'll do 10,000 boxes, and then 3 hours 15,000. So it's just constantly increasing or decreasing at a steady rate. Inverse variation is, instead of multiplying the constant times x, you're dividing the constant by x, so it's the opposite. Now, with this one, it's a little bit different. You can think of it like if you have to move all the chairs out of a school. It's going to take you a long time, but if about 10 students are doing it, a little bit less, and if 100 students are doing it, a lot less time. So it kind of has that reverse effect or inverse effect. It's a curved line, and it does not touch any axes. So it should look something like this here. So you can see that it gets really close, but it's never going to actually touch. These arrows are going to keep running as close as possible. It's important to remember what the graphs look like and just these two general rules, because most of the time they can actually answer a question about it. But let's actually dive into these formulas a bit more. So here's an example problem. Given that y varies directly with x, and y is 7 when x is 14, find x when y is 20. Alright, there's a lot going on. Let's back it up. Given that y varies directly, this means that we're going to be working with y equals kx. And what they also told us, they gave us this kind of ordered pair, if you will. They said when y is 7, x is 14. So we know we have the ordered pair 14, 7. And our goal is we have to find x when y is 20. So we don't know what x is, but we know that y in this example will be 20. Alright, the first thing we have to do is figure out what's the constant. And luckily they gave us an ordered pair, x and y, that we can just go ahead and plug in. So 7 equals k times 14. To split apart the k times 14, we're going to divide both sides by 14. And we're going to go ahead and find out that our constant is 1/2. So now what we do is we update our equation. So y equals 1/2 times x. And since we're looking for x, we're going to replace y with 20. So 20 equals 1/2 x. Now to get rid of a fraction like that, you wouldn't really want to divide. So we would actually multiply by the reciprocal, which is 2. So we're going to multiply both sides by 2. 40 equals x. So there's our answer. And this would be really easy to check. You just plug it back into the main formula with the constant. It should work out. Half of 40 is indeed 20. Let's go ahead and take a look at an SOL example. So, in which table does y vary directly with x? And it's very key, again, that you sort out which one you're solving for, if it's direct or inverse. So, we know that it should be steadily increasing, but what we can do is we can actually just work with the formula y equals kx. We can just find the constant and see if it's going to hold true. So in this first problem, if you notice, we have 3 equals k times 1. I just plugged in the 0.13 into the formula. So the constant is 3. Well, let's check and see if it holds true for the second one. 3 equals 3 times 2. 3 equals 6. That's not true. It failed, so it's not A. Let's go ahead and take a look at B. 1 and 4. So 4 equals k times 1. So the constant is 4. So let's plug it in the next one. 8 equals, since we know this is 4, we can change it to 4 times 2. 8 equals 8. Holds true. And let's see if it works for the last one. 12 equals 4, because that's the constant, times 3, which 12 equals 12. So our answer, which table varies directly, is B. Thanks for watching.